The moon is one of the most fascinating celestial bodies in our universe, and for good reason. It's our closest neighbor, and we've been observing it for thousands of years. Scientists and astronomers have been studying the moon for decades, and new discoveries are constantly being made. The latest of these discoveries is a miles-long structure that has been detected moving above our planet, close to the moon. This structure has caused quite a stir in the scientific community. What is this object? Does it pose a threat to the moon or us? Let's find out. Many of us may look up at the sky and see the moon as nothing more than a bright, beautiful object that lights up the night sky. But in reality, the moon has a major impact on our planet and our lives. The moon's gravity helps to moderate the wobble of Earth's axis, which can cause dramatic climate change. Without the moon, our planet would have a much more erratic climate, making it difficult for life to exist as we know it. The gravitational pull of the moon on Earth's oceans create tides that have guided humans for thousands of years. Tides are not only important for navigation, but they also play a critical role in the ecology of coastal ecosystems, influencing the distribution of organisms and their interactions with one another. The moon's size is also noteworthy. It is the fifth largest moon in our solar system, with a diameter of 3,476 kilometers. This is a relatively large moon compared to Earth with a diameter of 12,742 kilometers. The moon's size relative to Earth is important because it influences the moon's gravitational pull, which has an impact on the tides and the stabilization of our planet's climate. But the moon is gradually moving away from Earth at a rate of about 3.8 centimeters per year. This may seem insignificant, but over time, it will have a significant impact on Earth's rotation and the length of the day. Scientists estimate that in about 50 billion years, the moon will have moved so far away from Earth that it will no longer be able to cause tides, resulting in much smaller tides and less efficient distribution of heat around the planet. The consequences could be more extreme weather patterns and changes in the global climate. Without the moon, Earth's axis would be free to wobble more dramatically, potentially leading to more severe and frequent weather events like hurricanes, tornadoes, and even droughts. Furthermore, without the moon's gravity, the Earth's rotation would slow down over time, potentially disrupting natural cycles of plants and animals that are based on the length of day. However, these changes are unlikely to happen soon, as they are projected to take place in about 50 billion years. Interestingly, the moon rotates at the same rate as it revolves around the Earth, meaning that one side of the moon is always facing us. This phenomenon is known as synchronous rotation, and it's the reason why we only ever see one side of the moon from Earth. Despite the fact that humans have been observing the moon for thousands of years, it wasn't until the advent of space exploration that the far side of the moon was revealed. In 1959, the Soviet Union's Luna 3 spacecraft transmitted the first images of the moon's far side, providing an entirely new perspective on Earth's closest neighbor. While some people refer to the far side of the moon as the dark side, this is actually a bit of a misnomer. The far side of the moon receives just as much sunlight as the near side, but it's simply not visible from Earth. In fact, the far side of the moon is illuminated by the sun just as often as the near side. As the moon orbits the Earth, we see it go through a series of phases. This is because the illumination of the moon's surface changes, depending on its position in relation to the Earth and the sun. When the moon is between the sun and the Earth, we see a new moon. When the moon is on the opposite side of the Earth from the sun, we see a full moon. And in between those two phases, we see the crescent and gibbous phases of the moon. The moon's orbit around Earth is actually quite complex. It's not a perfect circle, but rather an elliptical shape. This means that at certain points in its orbit, the moon is closer to Earth than at others. When the moon is closest to Earth, it's called perigee. And when it's farthest from Earth, it's called apogee. On average, the moon orbits the Earth every 29.5 days. But what about the dark side of the moon itself? While we can't see it from Earth, we've learned a lot about this mysterious region through various space missions. While the near side of the moon is characterized by large, smooth plains, the far side is noticeably more rugged and mountainous. The far side has piqued the curiosity of astronomers, both professional and amateur, as they seek to uncover its mysteries. Their efforts have often led to startling discoveries that have been meticulously documented over time. One such discovery that has fascinated scientists is a mysterious structure beneath the surface of the moon's far side. The discovery was made by analyzing data from NASA's Gravity Recovery and Interior Laboratory, Grail mission, combined with topography from the Lunar Reconnaissance Orbiter. The structure is a miles-long metal mass located at least 180 miles beneath the South Pole Aitken Basin, a massive crater that formed billions of years ago. This enigmatic blob has sparked intense debate among researchers as they seek to unravel its origin and nature. The South Pole Aitken crater, where the structure was discovered, is the largest preserved crater in the solar system. The structure appears to be having an impact on the lunar landscape, dragging it down in a strange ovoid depression that sits more than half a mile lower than the surrounding crater floor, known as the Central Depression. While this extra mass isn't immediately visible from the surface, it is having an impact on the landscape, and the discovery of this strange mass only adds to the mystery, especially since the crater has previously piqued the interest of scientists due to its surface composition and size. The Grail Missions twin spacecraft launched in 2011, and it orbited the moon for nearly a year, precisely charting variations in lunar gravitational fields. The Grail team used this data to create the highest resolution gravity map of our lunar companion to date. The data provides a hazy picture of what's going on both above and below ground. The greater the mass, such as higher topography or denser rocks, the greater the gravity. These maps show a clear distinction between most of the moon's large craters and the South Pole Aitken Basin. Other large craters have mass concentrations, or simply mass cons, discovered by scientists at NASA's Jet Propulsion Laboratory in 1968. They appear as bullseyes on gravity maps, a central circle of strong gravity surrounded by a ring of weak gravity, and then another ring of stronger gravity. This effect is caused by the way the low-density crust and high-density mantle adjust after an impact. However, there is no such pattern in the South Pole Aitken Basin. To figure out what was going on beneath the surface, the scientists turned to calculations and developed a model that more accurately reflected the natural system by making new assumptions about the forces at work. The findings revealed a larger zone of dense material within the moon's upper mantle. Scientists propose two explanations of the subsurface mass. For starters, it could be a remnant of dense oxides formed during the final stages of cooling when the moon was covered in ancient magma oceans. However, the researchers lack a mechanism to precisely explain the formation of such a layer under the basin. So the question remains, why of all places would it be there? The mass could have been caused by an ancient impactor. The space rocket that formed the moon's giant basin was likely large enough to have separated into different layers when it first formed, so it had a dense metallic core and rocky outer layers like many of today's planets. The energy of the impact carved a deep, bowl-shaped crater on the moon on the fateful day of its collision with the impactor's metallic core, which smashed up inside the original hole. We hope you enjoyed this video. Make sure to subscribe, like the video, and watch these ones as well.